if anybody has like logistical questions about the course, let me know. If there's some issues that need to be addressed, let me know. Other than that, I'm just going to dive right into some slides. Let's talk about this. So let's talk about coding as a team, and mostly a lot of tips and tricks that can help you with teamwork. Of course, in this class, but some of these, and more importantly, after you graduate, when you're out there working in teams, just a bunch of good advice for you when working in those environments. Some of this advice will be specific to after the course, after graduation. But if you learn these things now, you're going to be well on your way to having a successful career. 222 times 2. 444. I don't think that's... You mean 221 times 2? I'm missing the joke there. So let's jump into this. So one thing that you're going to see out there, especially when you get on the job, you might not really see this unless your PM is really getting into measuring workload and output. But one thing you're going to hear is this person year or person month or person week or even person hour, however fine-grained they want to be. This is the amount of work that one person can do. I'll talk about person year for the slide. This is the amount of work that one person can do over 1 year. The reason this measurement is used, and the way you'll hear it used by management, is that a person year is equivalent no matter how it's broken down. So it can be one person working for 1 year, or it can be 12 people working for a single month, and they'll count that as equivalent in terms of how much effort was exerted on that project, or even some crazy combination. If 4 people work for 2 months and then one person works for 4 months, it's still going to add up to this one person year. So this is a metric you're bound to run into. Oh, -2. You put it on the second comment. That you're bound to run into is this this person year, person month. It's spoiler. Oh, not spoilers because it's right here. This is a terrible metric. It's absolutely horrible. If you're saying that 12 people working for 1 month can accomplish the same thing as one person over 1 year, you're probably not working in software engineering, because that just doesn't work like this in practice. Just not the way things work. So we can see there's this thing in Silicon Valley. I forget if it's the 10x developer or the 20x developer, whatever it is. It's some silly number. The productivity of a single coder can vary by very significant amounts. You've probably even seen this throughout your career so far, is that some developers can just produce a lot of code very quickly to ridiculous levels beyond what other people can do. And even a single developer in different situations, maybe you've had days where you just can barely squeeze out a line of code, and then some days where you can rip through hundreds of lines of code like it's nothing. The productivity can vary so much, even with the same developer. So if you have one of those developers who's one of these 10x developers working for a year, they're going to produce possibly 10 times more code, working code, functional, good code, than 12 people who are not 10x developers in a single month. So that's one of the issues that can be caused. Or if somebody's just having a good month or somebody's having a bad month, very, very different productivity out of those people. And that's okay. Like we just sometimes produce more code than other days. This also ignores what happens throughout that year. Did we have sick days? Was somebody out for a few weeks or whatever? Were they burnt out for a few of those months over the year? There's just a lot of things not calculated. And thinking of software development, for sure, can you, please ban me, just in yourself, I know the answer for me, can you get more done in an 8-hour day versus 8 1-hour days? For me, I think I can get a lot more done in a single 8-hour day where I could sit down, focus, put everything else aside, pull up the code base, pull up some documentation, and just start working and stay focused. And I can't quite do the same with 8 1-hour days. There's a lot of spin up cost when you start coding, you got to get your mind in the right mindset. Get familiar with the code base again. Remember what you were doing. Where you left off. Sometimes it can take half an hour or even a full hour just to get to the point where you can start writing code and being productive, because it takes that long just to get into what you're doing, to remember what the project was. Especially like if it's a Monday and you haven't touched the code since Friday, it takes a while just to remember what the hell you were doing, what was going on. So it's so that alone can be pretty tough. So there's a lot of issues with this measurement. If you run into this out there in the wild, it's probably from a business person who hasn't done any coding themselves, and they just want some metrics, some way of measuring anything, and you should tell them how bad it is, how inaccurate this can be. Good example. This is actually in a math book. I hope it was just a joke. I hope it was a trick question. But if you have an orchestra of 120 players, and it takes them 40 minutes to play Beethoven's Ninth Symphony, how long is it going to take for 60 players to play the same symphony? It's not 80 minutes. If you're tempted to say that, rethink your answer. It's not 80 minutes. So there's certain things that you just can't get done faster, and software engineering is one of those. I'll give more examples and talk about it some more, but just a quick thought experiment. If I combine two teams, if I took your team and another team and combined that into a team of 10, do you think you'd get more done? Do you think you'd get twice as much done? Do you think you'd get more than twice as much done with some good old synergy? Or do you think you'd get less than that? I think I could guess what your answer would be. There'd be a lot extra communication, a lot more mess, I guess. And part of that is the need for communication. Your team must stay organized to be able to produce in an effective way. So if you're organized, if you're on the same page, you know what needs to be done. Everybody on the team, I should say, knows what needs to be done. It's easier for everybody to work in parallel, so everybody can get their tasks done. And anytime you have duplicate code, you're going to, if two people are working on the same task, this is always wasteful. You can avoid that with more organization and more communication. I think the optimal amount of coders, it depends on the coders. For classes, I like 3 to 4. I'm sad that we have to go to 5 this semester, but it's just part of what's going on with everything. We have 180 students. We have to. I think that's pushing it. A team that's communicating well, usually with coders who are experienced and have been doing this a while, you can get like 8 to 10 can be effective. So there's no one answer for the optimal team, but for students who haven't really worked in teams a lot, I think 3 to 4 is about the optimal size, or maybe even 2, but I don't want 2 because part of the course, part of academia, part of why you're here is to learn how to resolve those issues. So I don't like teams of 2. They're probably maybe the most effective at your level, but you're not learning as much. To an extent, this course is meant to expose communication problems a lot, and actually this is kind of my capstone. I'll give it right now. My TLDR of this lecture, not necessarily TLDR, but my hot take on this lecture is there are a lot of tips in here that aren't necessarily on your rubric, but if you don't follow them, you're going to learn these things anyway because you're going to feel the pain of not doing them. So once you feel the pain of not doing the things in this lecture and the next few lectures, once you feel the pain of not doing them, you're going to take them more seriously when you get out in the world. So this is one of those lectures where I'm like, you should really do this. This is great advice. But if you don't, like, I'm not going to say I told you so, but you're still going to learn the lesson. It's a lot easier to learn these lessons through these slides and apply them and have your team apply them than not. But either way, you're going to learn this content through this course because you're working in a team. And bugs, if you have integration, no, I think I had the right word. Integration bugs. I feel like we call them something different. But when you have teammates working in parallel and their code just doesn't, even though tested separately, all your task tests pass. Once you both merge into develop, you have bugs because your code just wasn't compatible with each other because you didn't have enough communication, enough organization to agree on the APIs of how these two pieces of code are going to communicate. Somebody's building the front end and calling the methods from the back end, but the back end person building the back end API, there's just miscommunication on what these methods should be called, what they should take as parameters, what should the HTTP endpoints, what should they take, should they be get, post, what format should the data be sent. If you're not agreeing on all these things, you're going to have those integration bugs. Things are going to get messy. It's going to get difficult to turn that into working code, even though both your code worked fine separately. And that's something you can limit by being organized, having some top-level planning, and actually have an idea of what you're building before building it. Once you tracking tasks is, I know what I want to say here. This one is huge. Tracking tasks and no, code reviews is later. But tracking tasks, I'm going to say something similar with code reviews. Tracking tasks is something that's very hard to get developers to do. For whatever reason, it's just something developers don't want to do. And that's unfortunate because it's something that can really significantly reduce headaches and reduce bugs and reduce the disorganization of a team. Track your progress. Keep your PM up to date. Keep your team up to date. Update your issues with what's going on with each one of those issues. And it's really going to help track that progress. And it's also going to help if you have to add a developer to a team, especially after, when you're out there in the real world and you got to add a developer to a team. It helps them see what the progress is. What's the state of this project? If nothing's documented and you're just shoving commits and pushes into onto your branch with no tracking, you're not moving your cards across your Scrum board, and etc. It's going to be very difficult to onboard a developer and be able to get somebody up to speed quickly. And also, once something goes wrong, what happens? Who do we blame? Who do we ask for help? Who has the inside knowledge to be able to fix it? That's something that we absolutely need. It's not always just to know who to yell at, but who's fixing this thing. Because if you've ever been in a position where you have to read another developer's code, understand what it's doing, figure out where it went wrong, and then fix it, it's just a painful process. It takes a lot of time, a lot of patience to be able to go through that and figure out where this bug came from. But if if everybody's documenting their task progress, has good commit messages, etc., it's a lot easier to figure out what goes wrong. Because, that person who had that bug in their module, they might not even be on the team anymore. So if you have good documentation, it also helps after you leave a team or after somebody else leaves a team. It's something that can help the team stay on track. And yeah, reading other people's code, it's something you're going to have to do. You will have to read other people's code. But it's better to be reading it when it's working than when it's only reading it when it's a bug, if that makes sense, if I'm wording that right. Once you have a bug and you have to figure out that it's in somebody else's code and then read through it and figure out what went wrong, it's a lot tougher. If you can't figure out who is responsible for that code, that's tough. If you're reading someone else's code because it's working and you want to know how it works, we'll talk about code reviews. That's something you will have to do as well. You're still going to have to read other people's code. That's just part of this job, which can be a good thing. Knowing how other people do things can help you do things better as well. So this all boils down to communication. If you have too much communication, it's going to waste time, but too little communication wastes effort. So if you don't have enough communication, you're going to waste your effort. You're going to either write duplicate code, which we know is bad. You don't want to work on the same tasks as your teammate. It's just a waste. And you want to know what you're supposed to be working on. Don't work on something that's not even going to be part of the project and just waste your precious coding hours. Don't waste it. Don't waste all your mental effort on that. because it takes a lot of work to write code. You don't want to write code that's not going to be used. And then, of course, there's Brooks' Law. Adding programmers to a team that's already late, it's going to make the product even later. This is, if you've ever been in this situation, you know this is true. I don't know if it needs expanding on or explanation. Think about any homework that you did. Say you're working on a homework, and it's the day of the deadline. I'm sure you've all been in this spot. It's the day of the deadline. You're trying to crank out this homework. And imagine if you got like a lifeline. You got somebody else. You could pull in another developer at about the equivalent level of you in terms of being able to produce code, but who's never seen the assignment before and hasn't seen any of your code before, and throw them on a team and say, okay, they're going to help you with this homework now. Is that going to make is that going to suddenly get this project done? No, you're going to have to spend all your time explaining to them. They're going to be like, what the hell are you doing in this method? Oh, yeah, I was doing this. I was thinking this. I think it might work if we tweak it or something. Oh, yeah. You're going to spend so much time just explaining to them and getting them up to speed. It's going to make you even later. You're not going to hit that deadline. So, reality, things don't work out the way that we want them to ever. So this course is designed to expose these. Which is what I like about this course. We're just creating as real world experience as we can. And if you don't listen to the advice like this, you're just going to feel the pain of it. As opposed to like creating a typical cushy academic environment where most of your assignments have been, you might not get these experiences. But this course is designed to expose all these things, to be able to get you to see the importance of good organization, good communication, good documentation, etc. And getting all these things up and running. That's why we stress tests. That's why we stress the Scrum board. That's why we stress Git and commit messages and things like that, to be able to get that working well. So free trial of software development. And teams are never going to stay the same. This is very common out there in the real world. You have more people joining the team than who have been there for a while. This is, the way it works. Teams change around, and it's just something that we got to deal with. So if you have good communication, especially good documentation and good task tracking, good Scrum boards, and good practices all around with that, and especially like project management things, it's easier to get those new people up to speed instead of trying to explain, oh, this is what I was trying to do with this method and everything. If you have documentation, you just say, hey, go read the docs, come back to me when you're up to speed, and then you can fill them in on any details that they missed. And this is very common. I know I've done this before. It says I wrote the code, and I don't know anything. I have no memory of this code that I wrote. It's amazing how consistent this is. Like, it's easy to forget about the code that you wrote a while ago. So we want to get some documentation here. Documentation is important. I recommend using the GitHub wiki for some documentation, especially like defining your API endpoints. For example, if your backend has an API and you got these endpoints, that's one place where I really like to see documentation. Write that documentation, document every feature that your code is used for, not the details of the feature, not the details of your implementation, but the details of how your users can use your implementation. In this example, your users would be the front-end developers of your team, the ones who are calling the API endpoints and hitting those endpoints and using them for what they're supposed to be used for. They don't care how you implemented them, but you need to say this endpoint takes a post request that's a JSON string with these keys and these values in this format, and returns a JSON string with this in this format with all this information. You need to communicate all that and do it well. I know that sounds silly to say, but you're only going to write these once. You may tweak them, you may update them from time to time, but they're going to be read many, many times. You write documentation, and anybody coming onto that project is going to use that documentation to be able to get up to speed. So a little more effort in the writing aspect can save a ton of effort in the reading aspect of when people are actually consuming this documentation. You want to be able to save their time. You can spend 5 extra minutes writing it and writing it to be nice and clear. Then when they read it, it's going to save every developer a bunch of time when they're reading it. And also yourself. You don't want these developers contacting you like, hey, I read your documentation. It still just doesn't make sense. What's going on here? What did you mean by this? You don't want to be constantly pulled away from your work to explain your crappy documentation. So writing good documentation can really help, and can help that communication between your team. If you're documenting how to use your modules. Oh, okay, I wrote this method. This is how you use it. Whether it's a wiki on GitHub, whether it's something like Java Docs or whatever. Take some time to document those features of your code. So thinking of users, there are. You want to make your code as easy as possible for your users to use. In like front-end development, there's a lot of ways of doing this. One of the ways is to put all these common icons. You can look at all these icons and know what they do. You know what they do without reading any documentation. So making anything easier for your clients to use is going to help. And in this case, your clients are yourself. Oh, I thought that was on the slide. Are yourself and your teammates. So you want to build things in a way that's easy for your fellow developers and yourself to use. What language is this? Did I have a language? Did I have code on the screen? I didn't think I did. We're really not talking about code at this point. There's going to be a little here, but this is language independent. I believe it's Java. Just knowing Matt, he might have wrote it as Java code for the examples, but really they're just generic. It might have not even. Adding to the string class in Java, maybe that doesn't make sense. This is just generic code, we'll say. So naming, this cannot be stressed enough. Naming your methods and your variables, and really anything that you get to name it something meaningful. Let's say accept children and pets. Those can get names without real meaning. But naming your methods and variables, things that make sense, can just work wonders for communicating to other developers what they do. There's nothing worse than using a method with some cryptic, crappy name and trying to figure out what it does. In the worst case, you end up opening up that method's definition and reading through source code to figure out what it does. You never want somebody calling your method to have to read through source code to figure out what that method does. You can write documentation for it. That's all good. Write the Java docs. Write those comments above your method to tell everybody what it does, what parameters it takes, what ranges it does, what it doesn't do, etc. Yeah, you can have that. You should have that too. But just naming it can go a long way. These two methods, you don't see any of the implementation. You can't see the code for these methods. But I guarantee you can tell me what these methods do. Compare to, ignore case. You know what these both do. You know the difference between the two. It doesn't need any further explanation. Maybe you want to talk about the edge cases, what happens for certain Unicode characters or something like that. But it's self-explanatory what these things do. These are good method names. Equals ignore case, same thing. These are good method names. Region matches ignoring case. Again, good names. Actually, I'd argue this IC. This could use a better. Oh yeah, no, that's the point. Sorry. Region matches and region matches ignore case. These are good names, especially the second one. This is not. If we just had region matches with a Boolean named IC, this is not a good name. For some reason, I thought the method changed on the next slide. It's the same method. It was just bad in both cases. This is bad. This Boolean IC, we should at least expand this to ignore case to make it clear that if this Boolean is true, we're ignoring case. If it's false, we're not ignoring case. We're being case sensitive. But this is not writing code to be used. This is writing code just to make people mad. Whoever's calling this method, they have to use this Boolean variable with some obscure name when it's just IC. To figure out what that has to do, they're going to have to read documentation to figure out that this IC means ignore case. Make two different methods. Make one that doesn't ignore case, one that ignores case, and just be expressive in those method names. Don't try to have one method doing multiple things. Why do we have one method that's both ignoring case and not ignoring case? You might be tempted to write that. Please don't. Write this method, fine. You can write that method, but have that as a private method, or lead it with an underscore to let people know that they don't have to care about this method. And then write two methods, ignore region matches ignoring case, region matches case sensitive, and just have each of those methods call region matches with different values for this Boolean. You can be very expressive in your naming and still reduce your code duplication. You're not writing the same method twice, you're just calling the other method, but having just a little bit more code to be able to make things very clear to your user. Instantiate variables in your methods. I mean, you do that. It depends what you mean by that, beefy Indian kid. I don't know what you mean by that quite. But creating local variables in your methods, we do that all the time. Do it. Have parallel names. At most, you're saving 6 lines of code, I guess, if you don't do what I just, the example I just gave. 6 lines of code by not just writing 2 extra methods that call your underlying method. 6 lines of code. It's not really going to hurt you. It's not going to burden you that much. And it's going to significantly reduce the learning time to be able to use your code. Your fellow developers are going to thank you. They're going to like using your code a lot more. It's going to save them a lot of time because you wrote 6 lines of code that are 6 really easy lines of code. And I'm including the 2 lines that are just a closing brace. So name your things well. And it helps if it makes natural sense in the real world. If I have a method named employee.fileAnnualReport, I get a vision of an employee filing an annual report. Maybe the code doesn't literally file an annual report, but I know it's going to do something that's effectively the same as a human being filing an annual report. Employee.changeName, that takes a name. You know what these methods are going to do without seeing the code. You know what they're going to do. You don't know how they're going to do it. You don't know what variables they're going to use, what state variables they're going to manipulate or whatever, but you should know the effect that each one of these is going to have. If an employee needs a name change, you know you can call this method with a string given the new name, and it's going to work. Maybe you have to read some documentation to figure out the format. Is it last name, comma, first name that it wants, etc. But you know this is the method you want if you have somebody change the name. If you need to file an annual report, you know this is the method you want. A little less descriptive, without using metaphors, set up first use and disconnect. You probably don't know what these methods are supposed to do. These are very robotic. This is great for the machines. The compiler, I want to say JVM, but I want to get away from Java. But whatever. The JVM, it's going to know what you're doing, but your fellow developers are not. Like set up first use. I got a decent idea what that's going to do, but I don't really know when to call it. Probably right after the employee's created, but then why wouldn't it be in the constructor? Why do I have to call this method? Like, what is that going to do? Disconnect? I don't know what that means at all. Are they connecting to a server, or is this a phone call? I don't know what they're disconnecting from. Great for the machine, terrible readability for humans. And then even worse, maybe setting the color of an employee makes sense in your app. Maybe it's changing maybe it's Twitch and it's changing the color that it's going to display your name in the Twitch chat. So maybe that makes sense to you, the developer writing this method, but this doesn't make any sense to anybody who's just looking at the methods in your class. Employee.clone, the hell does that mean? Does that mean we're like cloning sheep? We're going to be creating another employee that's an exact DNA replica of that employee? Like, what the hell does that do? These only make sense these are terrible names, and they only make sense to the developer who wrote them. It's not going to make sense to anybody else. You're going to force other developers to read documentation. And honestly, if these are the names that you're choosing, you probably don't have good documentation, and they're going to have to read your source code to figure out what is going on in these methods. What does it mean to clone an employee? These are not metaphors. They're not intuitive. I don't know what these things could possibly mean. I can only guess, and I'd probably have to read your source code to figure out what these things are supposed to do. And don't be like this. It's on you. You have to make code that makes sense. This is all too common. I've worked with developers who are like this, and this is just bad. And they have these really crazy cryptic ways of doing things and horrible naming conventions and no documentation. And they're like, no, it's your fault that you don't understand what I'm doing. Well, no. I mean, to an extent, you're responsible for understanding your teammates' code. But there's a point where it's like, come on, man, you got to help me out. Like, don't name your variables those silly names. Or if you're working with a mathematician who wants to give every variable a single character name, like, no, don't do it. Some of that's on you as the developer to write code that's easy to read. And variable naming, I'm huge on variable naming. If you name your variables properly, in my opinion, meaningfully, I'll say, if you name your variables meaningfully, you don't really need documentation. Not much anyway. We call it self-documenting code, and with just your naming conventions, your code will just be readable, and it'll be clear what everything is doing, without adding extra comments. You don't need a comment. This is what I'm doing here. If you just name your variables properly. In some cases, you can't, and you have to have some comments explaining yourself. But in most cases, and I'm talking about within a method, you can just name your variables properly, and it's gonna be readable. Within a method, you should still have documentation for the API. What does this method do, and how should it be called, and what are its parameters, and what's its output, etc. But within the method, if somebody's ever actually breaking into reading your code and figuring out what you do step by step, the actual details of what you do, just with your naming of variables, you can tell them everything they need to know. So let's talk about some inheritance. We usually talk about inheritance as an ISA relationship, especially when we teach it. I'm taught inheritance Monday and polymorphism today in 116. And it's an ISA relationship. I said ISA about at least 20 times in today's lecture. We teach it as an ISA relationship, but that doesn't always hold. It doesn't always make sense to be an ISA relationship. For example, a square is a rectangle in the mathematical sense. So we can have square extend rectangle, but it doesn't always make sense in the context of an ISA relationship. House extends building makes a bit more sense. A house definitely is a building. That's and not just in a mathematical technical sense. A house is a building. So that's sometimes correct, but it's not always. Doesn't always make sense. In the case of a square being a rectangle, we can't always use a square where we can use a rectangle, because squares are rectangles, but they actually add more. They add more properties, more mathematical properties, but they actually restrict some of the functionality. A square is like a rectangle, except the length and width have to be the same. So it's actually more restrictive. So it doesn't make too much sense as an inheritance relationship for a square to extend a rectangle. So whenever we can use a rectangle, it doesn't always make sense to replace that with a square. It doesn't always work out the way we want it to work. If we're like, oh, square is a rectangle, I'm going to use squares instead of rectangles because squares are rectangles with more functionality. That's not true. They're rectangles with more features, and those features restrict the functionality. So, which brings us to LSP. This is a property where a subtype is usable wherever the supertype is usable. If we can replace the supertype with the subtype, then the LSP will hold. So if we see an example of the house and building, a house is a building, and the LSP holds for this. So if I have code, I want a new house, and I store it in a variable of type building using polymorphism, I can use this building and use all the building functionality, whatever I have, whatever methods I want to do, And I could replace this building with a house. If I store this in a variable of type house, these all still make sense. A house and a building can have a floor, an exit, zoning restrictions, traffic impact, and solar potential. Those all apply to house and building. So then LSP applies and is valid here. If we tried to do the same thing with square and rectangle, if we have a square, store it in a rectangle, we can't always replace this rectangle with a square. If we store this in rectangle, we can do all this stuff, but it doesn't make sense what happens when we change the width and length independently. If we said square R equals new square, so replace the concrete type with the subtype with the supertype, it doesn't make sense to replace that subtype of square if square is extending rectangle. It doesn't make sense to replace rectangle with square here, because what happens to say square dot width equals one thing, square dot length equals another? It just doesn't work. So this is a relationship, but LSP does not hold. And typically, I'd say you want to avoid these types of inheritance where LSP does not hold. But incidentally, against mathematics, it actually does make sense for a rectangle to extend a square. We can have LSP hold if a rectangle extends a square. Now all this makes sense. Where you, assuming that you have some setter code where you set the width of the square, and it's automatically going to set the length also to 2. And then when you set the length to 45, it's also going to set the width to 45. Assuming that's the case here in the functionality. Then it does make sense to replace square with rectangle. LSP holds. I would favor LSP. I would even say that should be the only thing, because we get what's before we get into dry, because then we get the benefit of being able to code to an interface, which means we're coding to the superclass and not the concrete class. So if I have building B equals house, this would be the same thing as if I said house H, for example. Speaking of single character variable names, if I said house equals new house, this code is going to be the same. But if I code to the interface, or code to the superclass in this case, and store this house in the super type that's furthest up the inheritance tree that I can get away with, and still have all the functionality that I need, that's going to be the I'll say best way to code this, is coding to the highest level subtype or super type that you can get away with, the functionality that you'll actually need, because then it makes your code much more flexible. If I want to change this to some other type of building, maybe I want to make a bank or a museum, I have to change one line of code, half a line of code even. New museum. All the rest of the code is the same, because a museum is also a building. A bank is also a building. If all my code is generically written to the super type, then it's a lot easier to make changes like that. You see this in Java. I'll give another Java example today. You always code to the interface, for example, list. If I code to the list interface and I say some variable of type list equals new array list, and then write all my code to use the list interface instead of array list, now if I want to later on change the implementation and use a different type of list, maybe I don't want to use array list sometime in the future, I want to use some different type of list, I just change that once. I just say new whatever type of list instead of array list, and all my other code can be the same, because I'm only coding to the list interface, and I'm only using the functionality that is defined in the list interface, not the array list specific code. So all your methods that take array lists, it's much better to write those to take lists and just use the list functionality, which is usually what we use anyway. We don't use the array list specific stuff in many cases. Then you can reuse that method no matter what type of list you have. As long as it implements the list interface, you can use that code and reuse that code in other projects, and etc. And even in the same project, if you decide I don't want to use array lists anymore, you just swap out the implementation and all your code is written to the interface. So who cares? There's no change needed and no retesting needed, no recoding needed, etc. If you go through all your code and change array list to list later on, you got to retest all that stuff. You probably got to rewrite your test cases, and it could just be messy. So code to the interface. Dry. Don't repeat yourself. This can save you tons of time if you follow this one. Any duplicate code anywhere, not just, I've talked about duplicate code earlier in terms of two teammates working on the same feature and duplicating your work like that. This is a little different. This is just within yourself. So any code that's going to be repeated multiple times in your program, find a way to refactor your code so you're not repeating it. The first thing you do with this that you've done so far in your career is write methods and functions. If there's something that you do multiple times, carve that out, put it in a function or a method, and then call that function or method in your code. Call it multiple times, but don't duplicate the code. This is also happens is why one of the reasons we use inheritance and polymorphism. If you have two classes with common functionality, factor out that common functionality, put that in a superclass, and extend that class so you're not maintaining the same code in multiple places. Because once you have the same code in multiple places, you're just asking for trouble. Because what happens if that code changes? What if it's not identical? If they have to be identical and they're not, what happens? What's the behavior of your program now when this object over here and this object over here have to have identical behavior in certain instances, and then they don't? What do you do then? So, and then whenever you want to make a change to that code, you have to remember every place that change has to be made, and it can just be messy. It's just asking for bugs if you're repeating code. So, but we can only do this when the code must always be identical. So if you are factoring out this code and using it in multiple places, make sure it always has to be identical. Because what happens when you factor that code out, you write this method, you call it in two places, and then you realize down the road that the requirements of one of those objects that calls that method changes, but the other one doesn't. Now we do have to split that into two methods again, and then it can make the code get a little messier in that way too. So make sure it's always going to be identical, or only factor out the parts that you do know are going to be identical, and then reuse that code wherever you need it. And of course, we often don't have bugs, we got features. There are a lot of features in our favorite programs. I'm blanking on examples right now, but features that came from bugs. It was a bug, and then they just decided, hey, that's kind of cool. Let's refine it and work with that. And code reviews. Finally, this is a big topic. This can save you so much time. Wave dashing in Smash. Yeah, I'm blanking on other examples too. We got one though. And so code reviews, this is one that I really recommend that you do. You have code review meetings with your team and look over each other's work. If nothing else, you're going to learn just by seeing how your teammates approach problems and how they write code. This can, the 100x might be debatable. Maybe you can argue with Dr. Hertz on that one, but tons of savings by reviewing code and finding those bugs early instead of waiting until all the code is merged into develop and then finding these bugs. If you're watching each other's code, looking at each other's code and reviewing it, it can really significantly help out. You can get the quality of the projects can ridiculously go up. And this is something that's common when code is merged. When you're done with your branch, you're merging it into develop. This will typically happen with a pull request. We're not requiring pull requests this semester, but it typically happens as a pull request. And then at that time, the rest of the team, or at least some members of the team, are going to review that code, make sure it fits with the project and with the culture of the team. And if it's approved, then it's merged into the project. If it's disapproved, you gotta go back and take the comments, edit your code, and then submit it again. One trap with this, you'll see this unfortunately. I don't think there's a real good way to get rid of this. But some code reviewers are going to pick apart the style of your code. And some cultures, some company cultures and team cultures are even to use code reviews to enforce style guidelines. I'm not a fan. Dr. Hertz clearly isn't a fan from these slides of picking apart somebody's style. I don't care where you put your parentheses. That said, if your company does have a style guide, which many companies do, just follow it. It should never make it to the code review stage because you should just be following the style guideline. But the code review really isn't the time to be picking apart these style things. So if somebody gives you style feedback, just throw it in the trash. That's useless information. But what should be reviewed is the structure, the functionality of the code, the readability of the code. Not just where did you put your parentheses, the style stuff, but did you use single character variable names, for example? That should probably be addressed in the code review. That's just not a style thing, that's a documentation thing. So typically this goes a few guidelines for this. It's usually about 200 to 400 lines, just a rough guideline for review. You have a meeting with explicit goals. You talk about what's going to be discussed, what's up for review in that meeting. And then everybody should come prepared, of course, just like any meeting. These should typically be less than 2 hours. After that, people get bored and just things start going wrong. Plus, it's just a waste of everybody's time after that. Limit it to less than 2 hours, and get to the content that you need to be talking about in that meeting. So there are different roles to be taken in this meeting. One, the moderator. This is the person who keeps everything on track. If the conversation is getting wandering away from the actual code, or somebody on the team is talking about style things and saying, "Oh, I don't know, I think we should put parentheses on separate lines," or that parameter list is too long. Let's break that into a few different lines or whatever. The moderator's job is to say, "Hey, let's talk about something that matters." The scribe, somebody who's taking notes of the meeting, so everybody can look back at the notes of the meeting later, and the author of the code can refer to those notes when they're updating, when they're fixing all the issues that were brought up. The reviewers, these are the people who are actually reviewing the code, and they need to talk about what issues they see and what needs to happen, and what documentation needs to be written, or what variable names need to be changed to make this code more clear and readable, so that when somebody's onboarded onto this project, they're going to understand what this code does. The author should just sit there and quietly soak up everything that's being said, and they shouldn't really be active part of the meeting. But if they are directly asked the question, they should be answering it. But they don't have a big role in the meeting itself. They've already done their job of writing the code. Now it's time for other people to talk about the code they wrote. And managers, they should just buy lunch. They should stay out of the way. If you have a manager, specifically a non-technical manager, if they're a business person, they need to shut up during these meetings. If you have a manager who wants to talk during a code review, unless they are acting as one of the reviewers and they have technical and programming knowledge that they can bring to the table, if they don't, tell them to shut up and get out. If they're even in the meeting, I'd argue they shouldn't even be there. They can get lunch, drop lunch off, and then leave. Get out of there. They don't need to be there. So let's talk about Agile for a minute here. Agile stole a lot of ideas from other areas outside of software engineering, and one of those things that they stole is working with partners. So obviously you're working in a team, but when it comes down to actually doing the work, working with a partner, specifically talking about paired programming, if you've heard that term before. So if two developers, instead of just one developer sitting down hacking at code, two developers sit down and hack at code. One of them's the driver who's actually writing the code, and the other one's watching and kind of mostly keeping an image of the big picture in mind and thinking about what's going on, more of the design role, and then the person at the keyboard is filling in the little details. It can help because when we're coding, we're pretty much only thinking of the smaller details. It's easy to get the big picture lost and lose the big picture. And also just having another set of eyes finding bugs. When you type a bug, it's a lot easier for somebody else who's not typing it to see that bug. instead of trying to type and see that as well. Dr. Hertz is a huge proponent of this. He's worked in teams of paired programming where he's seen significant changes, huge changes in efficiency, and decreases in the amount of time that are spent testing and finding those bugs and debugging. They can really see some great increases in that. So I'd recommend you at least try it. If you've never tried paired programming before, fire up a Zoom meeting, share your screen, have at least one of your other, I'd say exactly one of your other teammates. 3 people programming at once would just be a mess. But invite one of your teammates and just code together. If nothing else, you at least get some more interaction, more human interaction during this pandemic. We could all use more of that. If you just want to chat about your code, even that could help. And just remember, there's no I in team. You are a team. And then, of course, oh crap, there is an I in there. But let's just ignore that one. That's the end of the content. 2 minutes over, but I at least want to talk about this. Is Dr. Hertz? He built these slides. I didn't have the nerve, the gall to go with this, so I didn't put you through this. But when he's talking about teams changing, those earlier slides, he actually says, your teams will change. I'm going to take 2 members of each team and put them on different teams and scramble up all your teams. He actually waited until this slide at the end of lecture to say, just kidding. Haha. I didn't have the nerve to go through with it. I chickened out, but just so you know, that's what you were supposed to go through. You're supposed to be on edge that whole lecture, like, oh my goodness, this is happening. And I would actually like to one semester actually change the teams like that, but I've certainly never had the nerve to actually do that, randomly reassign the teams. I think you would learn a ton, but I don't know if I would live through the semester. I think you would all be so pissed off that there'd be a huge mutiny. So it's a tough thing to do, but you would learn so much with onboarding. I would even like to go as far as you completely abandon that project and all team members go to different teams and just completely rearrange everything and really test your documentation skills. Can a brand new team jump onto your project and figure out what to do and what's going on? So we don't do that. It's a little too cruel, partly because I want you to pick your own projects and stick with that project, something that you're ideally interested in. If you're on a random team, you might get a project that you don't like. But yeah, that's what this slide is supposed to be. You're supposed to be sweating that whole lecture. And yeah, keep going with your sprint 1. You know what to do by now, I hope. Make sure you're reviewing that grading rubric as that first demo comes up closer. Make sure you review the rubric and make sure you have every point that's mentioned on that thing.